Good afternoon, everybody, and welcome to the new GRAPHERGIA webinar session. We are slowly starting as people log into the webinar, but we want to respect the 1 hour timeline we've given ourselves, so we don't want to let you wait. And as it's also the lunchtime, let's get the best out of the 1 hour session we have. I'm Marill. I'm the communication and dissemination leader of the GRAPHERGIA project, working at AUSTRALO Marketing Lab. That is a SME based in Spain. So we can go to the next slide. So just to give you a little framework for today's session, really quickly before passing the floor to our two speakers of the day, I will quickly remind you what GRAPHERGIA is about, because this session is also for external stakeholders who work with graphene innovation related projects. I also present you the opportunity of working with us with the GRAPHERGIA Hub and remind you about today's agenda. And then we will start by the three presentation parts related to sustainability and eco-design of graphene innovations in the area of energy. So Matteo, can you please put the slide?
Day.
Good day. If you can just please all mute your microphones, that would be lovely. Of course, we will have time for questions at the end of the session, and we warmly invite you to interact in our chat. So what GRAPHERGIA is about? GRAPHERGIA is a European-funded research and innovation project in the field of graphene innovation. We developed an innovative pilot line for sustainable graphene-based energy harvesting and storage devices. We are running for 3.5 years, so until the end of March 2027. We gather 11 partners from 6 countries, and today our speakers are from Next Technology Tecnotessile from Italy and Adamant Composites from Greece. The total budget of the project is 4.5 million, co-funded by European Union. And so we focus on graphene-based materials applied in energy devices in the field of e-textiles and lithium batteries. And then the next slide. So again, welcome everybody who are joining the session. And I would like to present you really quickly the Graphene Hub through which we offer our webinars. So the Graphene Hub that we have put in place is a platform for collaboration and exchange of knowledge in the fields of GRAPHERGIA project, which are the advanced materials and especially the application of graphene, smart textiles and lithium batteries, which are our 2 use case focus areas. And the Graphene Hub is dedicated to stakeholders working with these 3 domains. And through this hub, we offer opportunities to host joint workshops, webinar like the one we are having today, and joint publications. And if you would like to work us or reach out to our partners, you can always contact us at contact@graphhergia.eu, and we will certainly come back to you. Now the next slide, please. So really quickly today, so again, I will pass the floor right after to our 2 speakers, Matteo Maccanti from Next Tecnotessile and Despoina Batsouli from Adamant Composites. But just a little reminder, the session is recorded, so you will also find it online afterwards. And also you can ask your questions on our chat or towards the end of the session so that our speakers can reply to you. So first we will deep dive to the eco-design principles applied in graphene-enabled innovations. And then we will focus on the sustainability assessment methodologies for product eco-design. And finally, the last part, we collect your insights with the social life cycle assessment survey. So with this, I wish you a good session, and I pass the floor to our speakers, Matteo and Despoina. Thank you.
Joo, ei tämä nyt niin kauhean kriittinen ole.
Good morning, thank you so much.
And okay. I present very shortly me. I am Matteo Maccanti. I am a sustainability expert and I work in Next Technology Tecnotessile since 9 months at least. And I have a PhD in sustainability assessment, in environmental sciences and sustainability assessment. And so for the reason here I'm working on the use, the application and study of methodology for the assess of the sustainability. Next Technology Tecnotessile is an Italian research center established in 1972 in Prato, that is a city near Florence in Italy. Is a public-private research center with at the moment at least 28 employees. Our work is regarding the consultancy, but in particular the research and development in many different fields regarding the textile sector, but not only the textile, also packaging, automotive, furniture, building sector, and so on. So we work on the modification of material, functionalization of the material, the surface of the material, but also the development and application and study of new material, bio-based material, and so on. And a part of this work, our work is regarding also the, for sure, because I'm here for this reason, the environmental monitoring and assessment and for inside the European project, regional and national project, but also for our client. So applying different methodology like the LCA, LCC, social LCA, and other methodology. And today I will talk to you about some of these methodology. Please, Despoina.
Yes, thank you, Matteo. Welcome everybody to this webinar. I am Despoina Batsouli. I am head of Advanced Materials Division in Adamant Composites, which is a Greek company and is located in Patras in Greece. Actually, I will present in brief our activities. Actually, Adamant is founded in 2012 with a growth over 25%. Our main facilities is in Patras, in Greece, and also we have some satellite offices in Athens and in UK. Adamant is a developer of complex structures, equipment and materials for European aerospace, defense and energy markets. And our research includes composites, nano-enabled technologies such as nano-enabled adhesives or nano-enabled textiles or prepregs, advanced concepts, qualification programs, technology piloting such as laser pilot lines, spray pilot line, and powder scattering, prototyping and IPR creation. And regarding our products, in our products includes satellite and launcher structures, deployables and complex shapes, panels and solar arrays, carbon fiber reinforced polymer tanks and struts, mechanical ground support equipment, engineering and design services, and also engineering support. And as we can see, we have some example of our prototypes and products in these pictures. That's from my side. So Matteo, we can continue with the next slides.
Thank you, Despoina. Okay, so today part of our presentation, our webinar is regarding the eco-design. And why we talk about the eco-design, we can partially understand also from the definition of the eco-design that is defined as a systemic approach that considers environmental aspects in design and development with the aim to reduce adverse environmental impacts throughout the life cycle of a product. This is the ISO definition. And we are talking about this because, as you know, European Commission, European Union are working a lot in the direction of these important aspects for the products. But why? Because as you can see, the design of a product from the design of a product can depend up to 80% of the environment and of environmental impact during the life cycle of a product. Half, so 50% of greenhouse gas emission and more than 90% of biodiversity loss are only estimation. Deriving from the extraction and processing of the raw material. So we need to design in a better way products in order to reduce the extraction and the consumption of raw material. At the moment, only 11.5% of the material that are consumed in European Union derive from recycle process. So we have to reach this value. But there are also economic advantages deriving from the eco-design approach. Because, for example, as this is only to data. For example, the cumulative effect of only the current European rules regarding eco-design are able to reduce 10% of the energy consumption of the production process of the regarding in this case the product that at the moment have rule for the eco-design. That is comparable to the energy consumption of Poland to have a measure. And regarding the year 2021, this reduction of 10% represent a saved in euros for more than 120 billion for consumers in Europe. So for our pocket, we reduce, we have less consumption in Europe. In April in 2024, European Parliament decide together with the Council to have a new rule, a new very important rule for the eco-design. That is the Eco-Design for Sustainable Products Regulation, ESPR. This is a cornerstone for the Commission approach for a more sustainable, a new way to the production of the products with in European context with a less energy and resource consumption. Some aspects that eco-design regard are, for example, the product durability, reliability, the reusability of the products or part of the products, the reparability, again, of the product or part of the products. We have to point out about the presence of substances that can reduce the circularity of products and materials. We have to point the attention of the energy use, and in particular the energy efficiency of the products, the resource use, and again the resource efficiency of the products. So we have to use less and use better more both the resource, so the material and the energy. So we have to define, European Commission are working to define an essential minimum value regarding the recycling content inside different products. We have to design the products in order to have an easy disassembly, remanufacturing, and recycling process at the end of the use of these products. We have to study and to reduce the environmental impacts, in particular the carbon footprint of the products is one of the main important aspects to study and to reduce. And again, we have to prevent and reduce the waste at the end of the process of the product. Please, Despoina.
Yeah. So the eco-design approach has an impact on many product characteristics, such as fewer materials. So manufacturing use fewer materials and less energy. And this protects resources and reduce emissions. Also, another characteristic is the easy to recycle. Ensuring easy disassembly means using materials that are easily identified, reused, or recycled. Another one is the use of biomaterials. So using a single type of material or a biodegradable material is best. Also, the long lasting is another characteristic. So shapes and sustainable materials will be long lasting in order to maximize the useful life of the product. Also, the multi-purpose, the reusability and recyclability is a key characteristic in which products should have multiple use to be suitable for reuse and to be manufacturing with recyclable materials. Also, we have to reduce the amount, so the products should be of a suitable size to have material and fuel consumptions during transport in order to reduce the carbon dioxide emissions, and also to be innovative. So technological innovations can optimize product efficiency and sustainability. So from this webinar, the green message is that sustainable design spreads the idea of sustainability with messages intrinsic to the product itself. The next slide, please. So as Matteo already mentioned, eco-design is a practice that seeks to reduce the environmental impact of products throughout their life cycle, from the design to the removal. And more people are adopting these practices in their daily lives and in industry in general. So we have summarized some characteristics and their examples of eco-designs. The first one is the design for disassembly and recyclability. So the products are designed so that they can be disassembled easily and recycled, which improves the efficiency of the recycling process and the waste recovery. An example on this characteristic is the mobile phone Fairphone from a Chinese company, whose parts can be interchanged and replaced to extend its service life. Second characteristic is the reduced use of materials. So during the manufacturing of these eco-sustainable products, the focus is on optimizing the amount of materials and energy. And in this way, the idea is to reduce emissions and to protect raw materials. In the next slide, please. So, yes. So the third one is the use of sustainable materials. In order, the products are manufacturing with sustainable and renewable materials, such as bamboo, cork, or organic cotton. And one example on this characteristic is the clothes brand Patagonia, which uses sustainable materials in its products and encourages repair and recycling. The fourth characteristic is the energy consumption reduction. So the products are designed to reduce the energy consumption, such as household appliances with energy efficiency label A+++. And an example in this characteristic is the electric car Tesla, which use high efficiency batteries and technology in order to reduce the energy consumptions. In the next slide, the fifth characteristic is the design for durability, in which the products are designed to be durable and reduce wear, which reduce the need to replace them frequently. And an example is, in this characteristic is the luggage company Samsonite, which offer a lifetime guarantee in its products and use resistant materials to prolong their useful life. And also in this company, in order to prepare some luggages, they used some cups, yogurt cups, in order to prepare their products. And the final characteristic is the design for reuse, in which products are designed to be reused for other purposes, such as the reusable water bottle that you can fill it with water and reused over and over again. So just a final message, the eco-design is a practice that aims to reduce the environmental impact of the products. In the next slide, so how we'll apply this eco-design within the Graphene project. Actually, we have a specific work package in which we will perform eco-design analysis and optimization of the critical parameters of the technology demonstrators. This is the one task led by entity, and also the idea is to apply this eco-design analysis in 3 different demo cases. As you can see, the first one is the all-in-one self-charging textiles capable of energy harvesting storage, led by Born. The second one is the self-powered structure integrating sensor for aerospace structures, led by Adamant. And the last one is the advanced graphene-based lithium-ion battery module prototype for space applications, led by Plione. So in the next slide, we will present some information specific to demo cases, and also Matteo will present how we will approach the eco-design on these demo cases. So regarding the first demo cases, in this demo case, we will deploy smart clothing and smart textiles for fabrics, and our research team will implement single electrode tanks on the surface of a t-shirt, as you can see, for energy harvesting and storage applications, and also on a belt for line gate monitoring. Regarding the second demo case, in this demo case, we will install and demonstrate a miniaturized tank-based self-powered wireless sensor in a scaled aerospace composite structure. The goal is to pilot a self-powered wireless temperature strain sensor that we will integrate into the composite fan blade that will enable more accurate data, leading to faster and better design. And in last demo case, this demo case focuses on a module prototype that will be designed, manufactured, and tested to validate the capabilities and advances of the developed laser-assisted fabrication technology that we have developed in collaboration with Forth on the system level, and based on the optimal laser script graphene-based electrodes and lithium-ion battery cells. So in the next slide, Matteo will present the approach of the eco-design analysis.
Yes, thank you, Despoina.
Welcome.
So, in GRAPHERGIA project, we will try to follow the pathway defined by the European Commission in order to design products that have the characteristics that we want to to have at the end of the project, but also in order to have a more eco design of this product. So we will start with the analysis of all the components and of the products and the material that are involved in the production processes in order to assess, in order to understand which is the recyclability and the reusability of the component that components the product. We will try to identify the chemical composition of the part that we that can't be replaced in the product, so the key components of the product. So in order to verify if these components are recyclable or reusable, and then we will analyze the secondary components in order to try to replace or perform or choose the material for the secondary components that are similar or the same that are used for the main component in order to have less part, less material, and a more easy disassembling and recycle process at the end of the use of the products. Okay, I just said this. Okay, and assess the technology available for recycling and the end of life treatment of the key components. So at the end, the idea, the goal is to have thanks to this study, this assessment, to have a more sustainable and more eco-designed product. Okay, we are at the second part of this webinar, so where I will talk about some sustainability, some methodology for the sustainability assessment. I like to start my presentation always with something like this. So the global context. So why we are talking about the eco-design? Why we are talking about the sustainability assessment? Not because we are hippie or we love to hug the tree, but because our world have some problem, and the problem that our home is living today deriving from two facts. The first is that we are 8 billion people. But is not the problem. The problem is that these 8 million people want to have too much things, want to consume too much resources, and don't want to have problem regarding the impact that the production, the use, and the disposal of these products have. So we have, in this situation, we've I put some example of representation of some of these problems that we're living each day. So, for example, the warming stripes that said to us that the temperature are increasing day by day and month by month, year by year. The representative concentration pathway told us that the situation for the future, the forecast for the future, are not so so good. Overshoot day, probably you know. So the fact that at the moment we are using, we are consuming resources as we have 2 Earth, but we have only 1 Earth, so we have to reduce our consumption. Ocean temperature that is increasing, the planetary boundaries that told to us that we are outside of the ecosystem capacity manage to manage our impacts are in many cases outside this capacity. So this is the situation. Is a complicated situation, but we have something to do, and we have the opportunity to improve and to Elena, microphone. Sorry, and to have a better approach to our planet, to our home. Okay, so we have to change our approach. We have to change our approach in the consumption of resources and in the impact to our planet. And as said Einstein, we cannot solve our problems with the same thinking we used when we created them. So we have to think in a different way. And the different way is the sustainability, the sustainable development. This is the philosophy at the base of our work, our reasoning. And probably you know, as said during the Brundtland report, in the Our Common Future report in 1987, that the sustainability, the sustainable development is that development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. So it means that all the people that live the Earth today and that will live on the Earth in the future must to have the same opportunity. And at the moment is not. Our way of consumption and production is not in this way. So from this conceptual basis, from this framework, we can define that there are three pillars. So there is the environment, society, and the economy. And this is a representation of the sustainability assessment. So the sustainable development that consider the right relationship between the environment, the society, and the economy, because the environment is the most important part of this pyramid. Because without environment, we can't have a society, and without a society, we can't have an economy. So we have to work for a better environment in order to have a better society and a better economy. And at the moment, in the last centuries, this pyramid was in the wrong way. So the first important things for the production process for the economy was the economy, not the environment. From this concept, there is an approach, a theoretical approach to the study of these three pillars, that is the life cycle thinking. Starting from the life cycle thinking, we can have different methodology to assess these different pillars. So the most important are the LCA, so life cycle assessment for the study of the environment, the social LCA for the study of the society, and life cycle costing for the study of the economy. Okay, here very short presentation of these three methodologies. So life cycle assessment is the most standardized methodology between the others, because there are two main important ISO standard, the 14040 and 14044, for the definition of a life cycle assessment. So which are the conceptual basis and which is the way to perform an assessment like this. Probably you know, but life cycle assessment is so a standardized and study based on a comprehensive assessment of all the material and all the energy that are involved in a production process, and also all the emission in the environment, so in water, air, soil, and also the waste management during the life of a product or a service. So I will say in the next slides, we try to study all the steps that we need to obtain a product or a service. The same, the life cycle costing takes into account the life cycle costs of a product during all the production process, and that involve different actors, different stakeholders that work together during the supply chain in order to obtain a product. And the same approach is that the one that are followed for the social life cycle assessment, and in this case we study the all the social impacts and also the potential impacts that could be positive or negative. Usually are negative, but we try to study and to assess on not only the negative but also the positive impacts. Okay, so as I said, in the life cycle approach, the most important, the most representative methodology is the LCA, because it's the more development, also because companies started to assess their production with this methodology, or a raw way of this methodology in 1970s. So are many decades that we work and then we study on this methodology. And as you can see, the assessment begins with the extraction of the raw material, so the transportation of the raw material and the use of the raw material, the disposal and the production of waste. Sometimes, depending on the boundaries that we want to consider, we can evaluate the distribution. Usually, at the moment, we always evaluate the distribution, so the sale of the products. Sometimes, depending also on the type of the products, we can consider the use of these products, but quite always we consider the end of life and the management of the waste deriving from at the end of the use of these products. We can consider also the reintroduction of part of this waste into the production cycle as a second raw material. Usually, this is a conceptual flowchart that we can arrange, that we can carry out for the study of a product. So we consider usually the upstream process, so all the activity that move on, that do during before that the raw material arrive to the company, to the process that we are studying. So as you can see, the raw material extraction, production, and finishing, the production of the finished products, as for example, also the auxiliary materials, the chemicals, the packaging, and so on, and the transportation of all these products to the company, for example, that we are studying. The core is the factory. So what happened inside the factory? So the consumption of energy, for example, and the consumption, I don't know, of diesel or other fuels for movement of the car and other of the truck and other stuff in the factory. And the downstream is what happens after the gate of the factory, so the sale of the products and the use and the disposal of the product at the end of its life. Okay, what's the time? Okay. As said, there is a standardized process for the development of LCA assessment, and usually this is the steps that we follow in the assessment of this methodology. So we start with the goal and scope definition. So we have to define why we are doing these assessments, which is the boundaries of the work that we want to consider, which is the functional unit, and so on. And we have to define very well these things in the starting point of our process, because all the step that follow depends on this first step. As you can see, is an iterative process, so we can modify, we can change something during these 4 steps, but it's better to define well at the starting point. The second step is the life cycle inventory, that usually is the most important part for example, for a company, is the moment that need the more effort, because we have to collect all the information of the data regarding the process that we are studying. So we have to collect all the inputs and all the outputs regarding all the raw material, the energy that are involved in the process. Then there is the life cycle impact assessment. So the data are collected, are elaborated in order to obtain the results regarding the impact category that we want to consider, that we want to assess. For example, one is the global warming potential, but also the water use, and so on. There are usually more than 15 possible impact category, depending on the method that we want to use. There are very different methods, but we can it depends on the scope and the goal that we define at the starting point of this process. And at the end, there is the interpretation of the results, where we try to understand which is the impact deriving from that process, and also to have a to see also in literature which is the state of the art. Sorry. Okay. Part 3. So as we said, in GRAPHERGIA project, we will assess all these aspects. So we will study the environmental aspects, the economic and the social aspects. But today we want to concentrate a little bit more on the social aspects, because we are here with you, with company, with some stakeholders that could be interested in the process, in the project. And our plan for the definition of the social assessment will follow two different pathways. On one hand, we will study all the supply chain that are involved in the process of the free demo case of the project using a specific database, that is the social hotspots database integrated in the software CIMA Pro, that permit to study all the social aspects during, as I said, the supply chain of our products. But we want also to assess the social aspects with a direct connection with company involved in the sector that we are studying with the project. For this reason, we carry out a survey in order to collect information direct from you, from company, and from workers with different our goal is to reach three different stakeholders. The one is the company, so we will try to reach the CEO of the company in order to collect information. There are in the survey 4 main sections for this question. So the first one is to address the general data about the product that the company produce. The second one is to address the working condition of the workers within the company from the eye of the CEO. The third one refers to the relationship that the company has with the local community. And the fourth section addresses the relationship of the company with supplier along the supply chain. So we will try to rebuild also in this way an evaluation along the supply chain. Another survey will be focused on the workers. So we will try to understand which is the wage, which are the working conditions, the health, the safety in the workplace, and so on, in order to understand which is the life of the workers inside the company. And then there is another part of our survey with the focus on to the university and the research institutes in order to understand also which is in the community, in the research community, which is at the moment the work on this matter, and also which is the most important aspects that we have to consider also for future work and for future development of this methodology. So now I stop my voice because here, if you want, there is this QR code that you can scan and where you can find our survey. So first of all, I want to say thank you for the people that are listening today, and in particular I want to say thank you to you if you want to answer to this survey. Is very easy. It's probably in 5-10 minutes you can fill in the survey. Now, if you have some questions, some doubt, we can answer during in the same time you can scan the QR code. Thank you so much.